Hello everyone, in this episode we are going to talk about clocks and clock chips. When we hear clock, our first reaction may be the current time and date. Yes, this is one aspect of the semiconductor clock concept, using the read key clock chip. Another aspect of the clock can be understood as frequency. Analogous to the microphone of us humans or a conductor of an orchestra, it can control the rhythm and logic of the entire operating system. For example, system clock or Q clock, they are actually referring to this concept. So, simply put, in the semiconductor industry, clocks mainly serve two purposes: providing frequency and time. Although it sounds simple, it is indeed not difficult for scenarios with low precision and slow pace. But if it is a high-speed system with high precision requirements, then it's not that easy. So in this episode, let's talk about the mainstream clock elements. That is, crystal oscillators and phase-locked loops. Another thing is the real-time clock chip tricks. Let's take a look at where the difficulty lies in clock technology. First, let's briefly discuss why systems need clocks. Digital circuits are mainly divided into two categories: combinational logic circuits and sequential logic circuits. The key point here is whether it is time-related. In other words, is the output signal of the sequential logic circuit time-sensitive? It is related to the previous state of the circuit. In other words, it is related to time. For example, the Q is a typical sequential logic circuit, and circuits like this definitely need a clock to operate. Well, it sounds a bit complicated. We can use the simple and beverage production line as an analogy. Imagine there are two buttons, with one button responsible for moving the cup. Another button is responsible for pausing and then pouring in the drink. To ensure the smooth operation of this assembly line, we need to alternately press these two buttons. The clock is the one responsible for pressing these two buttons. And the speed of alternately pressing these two buttons is the clock frequency. To ensure the stable operation of this assembly line, we must press the buttons accurately. Otherwise, the situation where the drink does not pour into the can will occur. Then back to the Q. The essence of the clock is high and low electrical signals, according to periodic alternation. This in turn drives various logic gates of the Q. The clock cycle is the oscillation period, which can also be understood as the time required to transmit a 0 or a 1, as shown in the pink part of the diagram. The blue part represents a machine cycle, while the green part is an instruction cycle. Clocks are not only applied internally in devices. Synchronization of clocks is also required between devices. Otherwise, the system will be underpowered.